So I'm Corey Dow, Technical Marketing Engineer, and as Matt said, I'm going to be covering the AOS-CX 10.13 update for EVPN-VXLAN with policy-based routing. So you see this is a pretty packed agenda. It's the same template that we follow for all of these presentations. I'm not going to read through these line by line, but you can see basically what we're covering, and we'll have a demo at the end, and then some extra resources to show you and help with the content that we'll be presenting today. Why policy-based routing? So traditional network routing is based on IPv4 and v6 routing destinations and table lookups, but it doesn't consider the source networks. And so certain use cases demand that both the source networks and destinations are evaluated to choose the path, and the path is not necessarily the shortest path to the destination. So some examples for security, firewall and IPS, you might direct certain subnets to one or more firewalls to permit or deny access. So got an example here with students and faculty at a university where you likely have different content filters for both of those types of entities in the organization. Dual ISPs, load balancers, WAN optimizers, and service chaining. These are all aspects to how policy-based routing is used in different organizations. And so our initial support with 10.01 introduced the feature for non-EVPN-VXLAN network implementations. And with AOS-CX release 10.9, we added PBR support for EVPN-VXLAN deployments. And you can see I've got the link there for the YouTube video that we have on the subject. So I encourage you to review that in addition to the content that we're covering today. So this allows L3 VTEBs to redirect traffic to a desired next hop over an L2 VNI. So unidirectional PBR policy is applied on the ingress inbound over a VLAN SVI interface. So this can be centralized or distributed gateways. So prior to 10.13, PBR couldn't be applied if the next hop was behind an L3 VNI. So for example, in figure 1 below, a class is configured to match 101.176.0.016 network with a policy to forward that when applied to the VLAN, it's supposed to forward it to the next hop 100.206.0.1. But you can see, so in figure 2, you can see that the policy never actually got applied. So in this case, when the PBR policy doesn't get applied, it just resolves to whatever's in the routing table. So this is what we address with 10.13. So this is just the matrix support about the features that were added with 10.13. So in addition to the L3 VNI, we also extended support for the L2 VNI use cases to the other platforms that you see there. And so as I just mentioned, so PBR with L2 VNI and now supported on 6300 and higher, just with the exception of the 8320, which doesn't support VXLAN. And so with L3 VNI support, the PBR policy is now applied to the L3 VNI context instead of the VLAN SVI interface, and you'll see that as we move forward. And just a note that egress policies are not supported on the 8400, so you can only do ingress. So the use cases, so this is just a review of what we did with 10.09. And so in this case, traffic from H1 normally takes the default route on border leaf 3 to reach the 192.168.200 network. You can see this is the normal route path. And so when we apply the PBR policy to VLAN interface 20 on the ingress VTEBs, this redirects the traffic through the L2 VNI tunnel through towards leaf 1. So this is how we alter the path in PBR. And specifically for different use cases for traffic, you may just want normal flows to go through the normal route path, but there just might be some flows that you want to inspect at a firewall. And this is how you would do it in this case with the L2 VNI. And so just an example there, we're redirecting traffic with destination 5001 to next stop 31.1.1.1, which is other side of this firewall that you see there. And you see where we've applied the policy to the SVI interface for leaf 2. Okay, and it's just the same example or similar example, just with centralized gateway. So all traffic to 192.168.200 from H1 and H2 normally goes through the default route on leaf 1 and out northbound, as you can see here. But in some cases, we may want, network security admins may want to inspect specific traffic and redirect. So an example here, we've got where we want to take DNS lookups for malware.com and gonefishing.com and have that redirected out to a firewall for inspection and obviously a drop at that point. And just, yeah, so same thing here, just the example shows that we apply the PBR policy in this case only to leaf 1 because that is the egress VTEP for the setup. So no need to apply the PBR policy on leaf 2 or leaf 3. Okay, and so this is what we've added with L3 VNI support with 10.13. So it provides support for next hops reach through an L3 VNI, so centralized and distributed NATcast gateways. So traffic in this example from H1 and H3 normally routes to the VXLAN fabric to leaf 2 because leaf 2 is directly connected to H2. So in this case, we have admins that want to redirect that traffic from H1 to H2 and send it out to border leaf 3, which is connected to the firewall over an L3 VNI. So in this case, the policy is applied to VLAN interface 10 of VTEP leaf 1. As you can see here, this is the ingress policy. That's what we provided in prior releases. And that's required to alter the route path to the next hop 10.120.0.1 you see on the other side. But we also, in this case, is we're going to apply the policy to the L3 VNI of border leaf 3 connected to the firewall to get it to route that traffic out to the firewall and back. And all other traffic going from H1, H2 would continue to use leaf 2 as the next hop in the VXLAN fabric. So for PBR details, so the requirements for the L3 VNI support, it's applied on L3 VTEPs, either centralized L3 gateway or distributed L3 gateways. The PBR policy is applied to the ingress VTEP of an SVI or an egress VTEP with an L3 VNI next hop. And the next hop must be on a subnet reachable by the egress VTEP, either over an SVI route-only port or an L2 switch over an L2 or L3 VNI. And it supports next hops that are reachable across a single fabric. Multi-fabric support has not been validated in this release. Recursive next hops that are of type BGP-VN, that it has to be of that route type. Other route types that we'll see later, such as BGP external, are not supported in this release. And just like all the other releases, class matches are based on the available parameters in CX, so UDP or TCP ports, source and destination IP ranges, and DSCP values. Both default and non-default VRFs, IPv4, V6, and VSX. And specific to the CX 10K, security policy is required to be created in the PSM for the traffic to be redirected via PBR. And it'll work with an allow all PSM policy, and the PBR actions performed after the ELBA DPU traffic inspection. And traffic is not allowed via security policy. If it's not allowed in PSM, it's dropped and therefore cannot be redirected to PBR. So under the configuration, so just kind of the same slides that I was showing before, but now we've got the actual configuration that we've applied here. So we show that the firewall redirect policies applied on the routed in interface for SVI 10 on leaf 1, and then also to the L3 VNI on egress VTEP for border leaf 3, and just showing the routing table what it looks like for this simulated firewall that we're sending the traffic to. And so next slide will show what the actual PBR configuration itself looks like. So we've got a class created here, PBR class, and in this case, just an example, right? So we're just matching an ICMP to redirect the traffic from H1 to H2 out to that 10.120.0.1 simulated firewall. And the PBR action lists are created to identify the next hop, as you see here, 10.120.0.1. And a policy of type PBR is created to pair the traffic class with the next hop actions. And policies are applied to leaf 1 and border leaf 3, but not to leaf 2 in this case, because that's the ultimate destination for the traffic. And this is same exact example, except just what it looks like from an IPv6 use case. Same sort of ICMP traffic class, and just we specify the next hop as an IPv6 address, and otherwise everything is applied as it would be in the IPv4 case. So for equivalent configurations, we did some comparisons with some of the other vendors, and they do things similarly, but with Cisco, you can see they use route maps to set the next hop instead of the classifier PBR policies that we have. So route maps are used to match and pair the next hops, and whereas we use classes and policies. And similar configuration when compared with H3C, HPE Commware. Commware uses ACLs and policy-based route policies that you can see here to set the next hop, whereas again, we use this classes and policies. So best practices, it's always useful, especially for troubleshooting, to add count keywords to the PBR classes so that you can verify the traffic classes are being hit. Otherwise, you really need to look at packet captures to see what's going on. So in this example below, we could see that the class entries for 30 and 40 are getting hit with traffic from subnets 172, 182, and 172, 185. So these hit counts are incrementing, so we know that the policy is being applied and matched. I've seen this from a few customers. It just makes troubleshooting a little bit difficult. So you want to avoid sequencing the class entries sequentially, like you see here, 1, 2, 3, 4. It's better to kind of use either the default or space them out a little bit in case you just need to insert something in between the policy. You can always resequence the class, but it's better practice to do it this way rather than to have to do it after the fact. Okay, so for PBR troubleshooting steps, generally you want to have a topology diagram ready with the IP address and interface details that you see here. And the recommended troubleshooting flow, you want to check that the VXLAN PBR configurations are correctly applied. As we mentioned with the class counts, to check that the policy hit counts are verified, that the traffic classes are matching. Check the next hop reachability via L2 or L3 VNI, and verify that the traffic is sent to the next hop IP. In most cases, that's going to involve a packet capture. And check for L3 forwarding loops or TTL exceeded. Now, this could indicate a problem with how you've got the policy set up. And I've got an example of that coming forward. I ran into that myself when I set this environment up. And finally, you want to check resources for TCAM exhaustion. All PBR does use the TCAM, so you want to make sure that it's not running out of resources because there are competing features for TCAM usage on the system. So just continuing just the flow chart, so you can see to check the EVPN-VXLAN PBR configurations, it's generally just a show PBR summary. In this case, you can see that we've got our 10.120.1 next hop address here. It's reachable, it's active, and these entries are probed by the system. So if you don't see them in here, it means that the next hop is not reachable. So as it says in the note here, only active next hops are going to be shown there. And as mentioned, check the policy hit counts to verify the traffic classes are matching. And so in this case, we're looking at border leaf 3 here. We're just looking at the policy hit counts to verify that this is incrementing for that traffic that we're inspecting. And just run that a couple times to verify that the packets are actually incrementing in that class. And so you also want to check the next hop reachability via the L2, L3 VNI. So in this case, I'm just showing that we can actually reach the destination because that's where the traffic is eventually going to flow to. So in this case, I'm just pinging the next hop router ID from leaf 1 to make sure that I can actually get to that destination. And as I mentioned earlier, so the route type also has to be of BGP EVPN route type. You can see it's reached through the L3 VNI 1000 in this case. Same example here. So you want to verify the traffic reaches the next hop through a packet capture. So this is, essentially what I did is I have a mirror destination here off of border leaf 3 where I've taken a packet capture. You can see the mirror session that I've created here. So I'm looking at the port 1148 where the traffic is coming back from the simulated firewall back into the border, and I'm just sending that out to a mirror destination so I can look at it, and I can see that the packets from host 1 to H2 are definitely arriving at the egress VTEP here. Yep, so that's what I just mentioned there. So if the traffic is not received at the next hop, if you don't see it here at border leaf 3, you're going to want to take the packet capture at the ingress side to see where it's leaving, where it's going to. So you may need to take packet captures at leaf 1 and leaf 2 to see where the traffic is flowing, since it's not if it's not reaching the next hop. So check for L3 forwarding loops or TTL exceeded. So this is always an indication of a routing loop in the environment. I ran into this myself. So in this case, the traffic reaches the next hop IP address, but never actually reaches the destination. So you can see from my host 1 here, I'm doing a ping, and you can see the time to live is exceeded. And I thought it was a forwarding loop here on leaf 3, border leaf 3, when it came out here. I thought it was a loop between border leaf 3 and the firewall, but essentially what was happening is the border leaf to the firewall, back to the border leaf, was sending it to leaf 2, but we had a PBR policy that was applied here for leaf 2. The egress policy is applied here. So what was happening, it was just kept looping it back and forth between leaf 2 and leaf 3 and never actually reaching the destination. So all we had to do is just remove the PBR policy from leaf 2 in this case, because again, that's the ultimate destination for that policy. So just pay attention to that. If you're seeing any of this behavior, you definitely need to inspect your PBR rules and make sure that you've got things flowing the way that you need to. So for check resources for TCAM usage, so it's just a show resources command. And so this is just an example that our QA NTL team sent us, where the TCAM is exhausted in this case. So you can see the ingress TCAM entries is at 0, so there's no free entries here. To diagnose that sort of thing or to detect it, you can, well, for one, the PBR summary will show you that the PBR policy isn't in effect, but you can also look at the show events here. Show debug buffer to see what's happening. And so you can see in this case, the entry installation failed because the PBR policies, the TCAM is full in this case. Okay, so if we're onto the demo, so I've been showing you this slide pretty much all along. So this is what the demo is going to entail. Is we're going to have some ping traffic going from leaf 1 to leaf 2. And again, this is just an example, right? I mean, in reality, you're not really going to have a PBR policy with ICMP as a traffic class, but it is helpful for if you're setting this up for the first time to verify that the traffic is flowing, the way you'd expect it. So in this case, we're applying the policy to the ingress VTEP here on leaf 1 and also to the egress VTEP on border leaf 3. And so what we're going to do is we'll just see in the demo that the pings are going where they should expect to go, where we have the policy applied, and when we don't have the policy applied, the traffic either reaches leaf 2 or it goes to border leaf 3. And also that depending on the traffic classes, it's not all or nothing, right? The traffic class determines which traffic you're going to have sent to the next hop or which that you're not. So in this case, all of the traffic, so deny SSH traffic, we're denying the traffic from H1 to H2, but any other traffic, so like ICMP and SSH, you'll see them as traffic classes, but any other traffic would normally just go straight to leaf 2. Okay, and so I've prepared just a kind of a CAN demo, just so you don't have to watch me mistype commands over and over again, and just to speed things up a little bit. So for orientation, you can see I've got the 3 leaves there at the top, leaf 1, leaf 2, and leaf 3, and the 3 hosts that are at the bottom as well. And so we'll see how this configuration is going. Okay, so in this case, we're just showing the BGP configurations on each of the VTEP peers. And so as we can see of note, just single fabric, 65,000, on each. And this is where we're showing the tunnels between each of the VTEPs. Leaf 1 is router ID 1111, 2222 for leaf 2, and 3.3.3.3 for leaf 3. So everything is up. The tunnels are all active. Okay, this is where we're just looking at the SVI for VLAN 10, and you can see in this case, we don't have any of the PBR policies that are applied. And this is just showing the firewall connections for VLAN 1000 and 1001. So that's reaching just a 6300 I have connected as a simulated firewall at the other end. And this is where we're pinging the next hop just to make sure that we can reach the simulated firewall, because this is ultimately where we're sending the traffic out to or redirecting it. Okay, and this is where we're looking at our classes here. So we've got an ICMP class and an SSH class on leaf 1. And we're eventually going to apply that in a policy, a PBR policy, to redirect the traffic. And so we've got our singular action there just to send to next hop 10.120.0.1. And on the side as well. So yeah, so we've got our list the PBR action list firewall 1 on that. Leaf 3 is what we're looking at. So this is where we're looking at our policy commands. So we've got a policy for firewall redirect. And you can see where we're ultimately going to drop the SSH traffic and redirect the ICMP traffic. And just showing we don't have the PBR policy applied at this moment. And so we're looking at host 1 at the moment, and host 2, which is verified connectivity even before we apply any type of policy. So we can reach from H1 to H2, we're able to ping, and H1 to H3, host connected off of border leaf 3. And we're just going to leave that traffic running. And this is where we're going to start applying the policies. Yeah, and so we're looking at our PBR summary. We can see that 10.120.0.1 is reachable. And this is where we're going to apply the L3 VNI policy, which is, again, is new with 10.13. And I've changed my focus down at the bottom, so you can see we've moved from the topology, and now that we've got a packet capture going, we can see once we applied that policy, we're now receiving that traffic from the ICMP traffic from 10.10 to 20.20. And this is where we're looking at our hit counts to verify that we've got increments here. So yeah, you can see we've got ICMP traffic class is incrementing. So we know the PBR policy is working because clearly we're seeing the packets arriving at border leaf 3. And this is where we're just shutting the interface for 1147 so that connects to the firewall. And so you can see down at the bottom, we stopped incrementing the ICMP traffic coming in because it's no longer being received at the firewall, but you can see the pings are still successful. So the PBR policy is just not effective at this moment. And this is where we're unshutting it. So we'll get the PBR policy flowing again. Again, just verifying our hit counts are incrementing. Which they are. And just taking a look at it from both sides. Okay, and then this last step, all we're doing is showing that the different traffic classes are permitted or denied. So in this case, we're denying the SSH traffic. So you can see we can't reach 20.20, but we were still able to ping it. And just showing that there's no traffic that's actually arriving there for the SSH. So that's not incrementing, but you can see that we're incrementing here on the leaf 1 for the SSH traffic. And so that concludes the demo. And with that, I conclude the presentation, and thank you for your time.